All right, let's talk about a tool that literally turns uncertainty into prediction. It's called the Life Table, and it's this secret engine that allows entire industries to price the priceless.
I mean, think about it for a second. How can a life insurance company make a promise to pay out when you die, when for any one of us, that's the biggest unknown there is? How could that possibly be a sustainable business?
Well, here's the trick. They don't even try to predict your future. They can't. Instead, they zoom out. They look at the incredibly predictable patterns that show up when you look at millions of lives all at once. The secret isn't fortune-telling, it's all about probability.
And the tool that makes all of this possible? It's the Life Table. This is the bedrock, the absolute foundation of actuarial science. It's how they turn that massive, widespread uncertainty into a risk they can actually calculate.
So what exactly is it? Well, at its core, a life table is basically a statistical story of a population. It's a chart that follows a hypothetical group of people right from birth all the way until the last person has passed away, and it shows the chances of surviving or dying at every single age along the way.
And to start telling that story, you need a starting point. So actuaries pick a big, round number to kick things off. This is called the radix, and usually it's 100,000. Just think of it like starting a giant simulation with 100,000 brand new lives at age 0.
Okay, so we've got our 100,000 people. Now what? Well, the whole table really just works on two very simple connected ideas: keeping track of who's still around each year, and because of that, also knowing who isn't.
The first and most important job of the life table is to track the survivors. It's a column, often called LX in actuary speak, where X is just the age. It simply tells you how many people from that original group are still alive at the start of any given age.
And you can see that journey start right here. We begin with our 100,000 people at birth, but by the time they hit age 1, historical data tells us that, on average, only about 99,186 are still with us. Fast forward to age 5, and that number's down just a little bit more. The table just follows this number as it ticks down year by year.
And this is the really elegant part. If you know how many people were alive at the start of age 1, and you know how many are alive at the start of age 2, then you automatically know exactly how many people must have died during that year. It's just simple subtraction. So that brings us to the second key column, DX, which is just the number of deaths in a given year. See? Well, LX is the number of people who make it to their birthday. DX is the number from that group who don't quite make it to the next one. They're just two sides of the exact same coin. Let's look at a real example. At age 0, we start with our 100,000 survivors. The table shows 814 deaths during that first year. You do the math. 100,000 minus 814 is 99,186. And that's exactly the number of survivors we have at the start of age 1. It's a beautifully simple process that just repeats, all the way down the table.
And the power really is in that simplicity. From just these two basic ideas, survivors and deaths, this one table becomes the foundation for calculating all sorts of probabilities. And from there, you can figure out the price of an insurance policy.
But a life table is so much more than just a pricing tool for actuaries. You know, when you actually visualize the data, it tells this profound story about the shared patterns of human life.
So this isn't some stock market chart. What you're looking at is basically a data portrait of the human lifespan, built from millions and millions of data points. It plots the probability of dying at any given age, and it has some really distinct and kind of fascinating features.
We can really break this life story into 4 chapters. First, you see that sharp spike right at the beginning. That's infant mortality. Then, thankfully, the risk plummets and stays low for a while, until you see this distinct rise in the late teens and early 20s. That's often called the accident hump. From middle age on, things change, and the probability of death starts a long, steady, and steep climb, which peaks around age 80. Now, after that, the curve falls. But that's not because it's suddenly safer to be 90, it's just because so few people from that original group have survived that long to begin with.
Now, the table we've been looking at is a fantastic starting point, but of course, real life is always more complicated. So actuaries have to adapt this tool to account for specific groups of people and any new information they have.
That standard table we saw uses what's called ultimate mortality. That's a fancy way of saying the only thing it cares about is your age. But what if you know more? What if you're looking at a group of people who just passed a full medical exam to get life insurance? You'd expect them to be healthier than average, right?
And that is exactly where select mortality comes into play. It's a much more refined model.
It doesn't just look at your age. It also considers the duration, basically how long it's been since you were selected into that healthier group. Now, the health benefit of passing that exam does wear off over time, but for the first few years, it's an absolutely crucial difference.
So why does any of this matter to the rest of us? Well, this isn't just an abstract tool for insurance companies. Life tables are fundamental for public health officials trying to plan for the future. They're essential for governments trying to figure out if pension systems like Social Security are going to be solvent. And they're the bread and butter for demographers studying how populations are changing. This thing has a massive impact on society.
And that brings us to one last thought to leave you with.
You see, the life table is this incredible snapshot, a story told with data pulled from generations of our past. But as medicine advances, as technology and society keep changing, so will our patterns of life and death. And that leads to a fascinating question. What new story will the life table of the future tell us? And what will it reveal about the lives we haven't even lived yet?